Welcome to Cloud Native Development and the new corporate mobile app. Here's what we're going to be talking about today. My name is Brian Fromme. I'm a Technical Alliance Manager here at SUSE. Let's dive right into some of the goals and needs behind the reasons of why we're building this corporate mobile app. First, like all good developers, let's dive right into the what. Of course, the typical mobile app has a front end, a user interface that comes along with, we want to be able to do good user experience. And then there's the back end, which is the traditional place where most of the hard work and computing really gets done. That's changing a lot in the industry as processors become more powerful at the front end, phones and tablets, but also through software technologies like AI is coming to phones and tablets. There's a lot of new technologies at the user interface side that really allows us to do more computing there. But nevertheless, for our application, most of the work's happening in the back end. And let's talk a little bit about the why of why are we trying to do this. So digital transformation is really an opportunity for our company to get closer to our customers in new ways and engage with our customers by creating services that bring them closer into the fold of the work they do with us. So that's a business opportunity. So we want our applications to really do that for us, to create new services and create new revenue opportunities for us. But digital transformation is hard for a number of reasons. First of all, I like to use the phrase, speed is the new IT currency. When we look at digital transformations and the competition in the marketplace, it used to be that years ago, web application development might happen on the order of months to years. Now we're looking at it the other way around. Digital transformation, edge services, mobile application services, these things are happening in the order of months to weeks, or even days, where new code is being pushed to an application regularly. And so that kind of process change is very different for many organizations. The whole notion of how we get closer to our customers and listen to our customers through agile methodologies is a transformation for many customers. So that can be a real challenge for a customer organization to transform themselves into an agile organization. And then, of course, there's the technologies themselves and the automation that's required to make all this speed happen for us. So we'll talk about those aspects. First, let's talk about cloud native transformation. There's a wonderful book that's published by O'Reilly called Cloud Native Transformation. And in fact, I'll be working with Container Solutions, the company that publishes this book, to do a SUSECON presentation called Cloud Native Maturity. So have a look at the sessions and see if you can find that session and have a listen to that if you're interested in this topic. That's one of the pieces of the puzzle of what companies need to do. As I mentioned, methodology and process is a big component of the need to change in the way we build these new applications. Of course, there's the technology itself. We are looking to build with a microservice architecture. Of course, we don't just dive into microservices and change our whole application overnight. We transition into a microservice by learning and growing as we get better at that capability. There's the automation that I mentioned through various forms of automation and infrastructure as code that allows us to deploy our infrastructure stack much more reliably and much more quickly. And then finally, there's the security across the life cycle. We've seen through SolarWinds and other things happening in the market today where it used to be that issues for security were typically at the production side, right, at where the application runs. Now we're seeing that it happens anywhere within the development workflow. So we need to be cautious of considering security throughout our application process. All right, let's dive deeper into the application in terms of its requirements and design. So we're looking at building a product support application that brings our customers closer to our product support teams. And while this may seem a little mundane, it's actually really important for our customers to engage with their support capability when they need it quickly, reliably. And we want to excite our customers in terms of that. We don't want that to be a boring process. We want that to be an interesting and fun process that perhaps a customer even looks forward to engaging with support in a certain way. So our service needs to reflect that. And then the more we can learn about how to create these kinds of services, the more we have opportunities to increase our revenue through offering new services that are for pay services. This particular service is a free service, but we want opportunities to provide revenue generating services. Let's talk a little bit about some of the requirements for our application. So, of course, we need to reach into corporate databases and servers to get information about the customer's subscription capabilities and what they're licensed to get from us. We want to connect customers with their counterparts in our support organization. We need to make technology choices about how to do that. We want everything to be modern and fun, as I mentioned. We want to find ways to really engage and thrill our customers so that they're excited to think about, wow, I have to contact support, as opposed to, I have to contact support. So, we're looking for ways to invigorate the technology that we provide to our customers. And let's talk a little bit about some of the design characteristics. On the front end, we're looking at using React Native, and that's for native applications on iOS and Android. But we also want those interfaces to be very similar, as compatible and similar as possible on web browsers. So those are some of our design objectives. On the server side, some of our design objectives are around utilizing a microservice design or architecture. Again, as I mentioned, we don't just leap into it's all microservice based. We probably transition in certain ways. We want to containerize the components that go into our microservices. We want a highly portable system. We might deploy in our own data center, but we might decide to deploy in public clouds or a managed service environment. So we want the flexibility to do that, and to do that quickly. So we don't want to say, oh, it's going to take us a week or weeks to move our application somewhere. We want to have the separable, portable capabilities so that our application can run easily in any of these environments. Other development goals: we want our teams to learn fast and to really stay and become modern by leveraging modern technologies and leveraging cloud native development techniques. We want to be agile, and that's a whole methodology and mindset. We want to listen to our customers. We want to engage our customers through what we're doing in development. We want to ask them, what do they like? Do they like the things that we're giving them? And if they don't like that, what would they choose instead? So those are agile approaches that we want to incorporate into our development approach. We want to have fun and be happy. The more fun we have as developers, the more fun the result will be, the more fun our customers will have with engaging with the technology that we create. On the implementation side and the DevOps, structure of what we're building, let's talk a little bit about some of those components. So I mentioned we want a cloud native or cloud-based server model, right? That may not be that we're jumping right to the cloud. We may deploy that in our own data center, but we want to take a cloud-first approach. Portability, I mentioned, we don't want to be tied to any particular vendor technology, whether it's hardware or software, nor any particular vendor technology in terms of the service that we're gathering or leveraging, like a cloud service provider. So we certainly don't want to be tied to one cloud service provider where we leverage their technologies, and then it's difficult for us to move away from that. We want to build on top of standards for the same reason, so that we're flexible in terms of the capabilities that we have and that we can move, so that it's easy for us to move around in our application. So vendor lock-in is really important to us here. And then automation. We want to be able to automate everything about the way we build our application and deploy our application stack, as well as the application that sits on top of that stack, so that it's really a push-button operation. And the better we get at that, the faster that will all happen for us, so that we can deploy very quickly into new operating environments. So let's talk more about the back-end structure and DevOps. So if you look at the graphic here, we start from the bottom up. There's the hardware choices that we make. If we're talking about on-premises data center kind of technology, we'll be choosing a vendor and buying hardware from someone. But if we're in a cloud environment, we won't. That's the hardware choice is done for us. There's the software and software stack that sits on top of that. So we want to make choices that I've mentioned are standardized choices that allow us the flexibility to move around and not be locked into any particular vendor environment. There's the automation and infrastructure as code that we leverage so that we can easily build up our software stack and then deploy our application with a push of a button. There's the program itself. There's our deployment of our application and how that's running, and the security and governance and policy that all goes together into that application, as well as the monitoring and logging and all the capabilities, alerting of how we keep track of what the application is doing and how it's running. And then finally, there's teaching people, right? Our developers are learning things, but the people who operate this for us, whether they're from a third party or in our company, need to learn about this, and we need to learn certain technologies. So we need services and training to go together with all this. So our technology choices then really come down to some of the key tenets that we just talked about. So we're looking at SUSE technology because one of the keys that we see is that it doesn't lock us in to a specific vendor's approach. We have the flexibility to choose Linux, but we get flexibility from not being locked into SUSE's Linux in particular. It gives us much more flexibility. Same at the Kubernetes layer. We want to be able to leverage a standard Kubernetes and deploy automation and all sorts of features on top of that Kubernetes, but not be locked into one Kubernetes provider in particular. And SUSE Rancher really helps us with that, and Fleet as well, as the ability to manage multiple and many of these Kubernetes instances across a wide range of different vendors. Those technologies help us to manage the different types of Kubernetes that we've chosen, so that we think of Kubernetes as a standard layer, but that it's easy to manage and automate on top of that layer. Other choices are SUSE Linux. I mentioned, we'll talk why we chose that. SUSE Linux base container image, so that we can have SUSE Linux as our base for the containers that we're creating, so that we know that we're based on top of a supported, secure operating system capability. And then SUSE Manager as a piece of the puzzle to manage the operating system and infrastructure, so that it's easy to keep track of making sure that the infrastructure is governed the way we want it to be, that it's secure, that updates are applied as needed. So we need tooling at that layer as well. And this is just a graphical view of the same thing. You can see from the bottom up, we've got our different types of operating environments. And one of the things that I haven't talked a lot about is the developer operating environment. But that's one of the pieces of the puzzle that we need to keep track of as well. So you can see we've got developer, data center, cloud. We're not as interested in our application with the edge, but we know there will be edge opportunities for our company in the future. So we want to look at that as part of our future of what we build and architect towards. There's the Linux layer itself that gives us the portability to think about moving around between these different operating environments, whether they're cloud or IT data center. There's the Kubernetes environment, which is the standard, I call it application infrastructure, the place where application lives and the policy and governance that goes with that. And then there's the support and services that we need to train the people that operate with us at those layers. And a little deeper on the security side of all this, we really want to consider security across that whole stack of infrastructure into our application itself. So we need a wide range, we need to deploy and leverage a wide range of security technologies, whether they're dealing with certification of hardware and operating system software, whether they're dealing with managing the infrastructure like the operating systems and the software stacks, the security at the container level of what the various containers are and how they're, as they become updated, we need to be sure that they're being updated with reliable code. So we need security at that layer as well, all the way up into our developer processes where we're pushing new code out to our application infrastructure. So you can see we've got to consider security across the whole software stack, or else we're really only considering part of the security challenges. And I mentioned why we chose SUSE Linux Enterprise as a base of our Linux layers. And that's because what we're looking for is the modularity to choose technology components that are basically componentized and structured for us, rather than having a developer pick a version of a particular piece of code and say, oh, we'll inject that into our build. We'd like to make sure that we leverage as much as we can standardized technology that's built into modularized capabilities so that it's easy for us to deploy and manage, but it's also standardized. So SLES as a modularized operating system really gives us that capability to leverage as much standard technology as possible, whether that's in small footprint environments in the cloud or in our data center. So Rancher sits on top of that operating system environment as it manages the different Kubernetes that I mentioned, from our data center into our either managed service provider or our cloud provider, if we so choose to use those. And we use SUSE Rancher to manage those different Kubernetes environments, but not just the Kubernetes software itself. It's the components of software that we add on top of that for policy, user authentication, governance, security. All of those components need to be managed and kept track of, and SUSE Manager helps us with that across our landscape of different Kubernetes environments. And another thing that we like about the SUSE Rancher model is that there are a number of ready partners that are component technologies that are already built into Rancher. So a good example is Okta's user authentication and single sign-on capability. We choose Okta as the technology we want to use within our authentication capabilities within our application. And it's great to know that we can just bring that into our managed environment very easily, and that there's already an integration there, and it's easy technology choices for us when there's already pre-bundled capabilities here. Another aspect is, I mentioned security across the security stack or software stack, from the infrastructure up to the application itself. So we're leveraging cloud native security with a technology called NeuVector, which allows us to do scanning of the components themselves, the containerized components that we're utilizing in our whole development workflow, whether that's early on in the development process or in the production stack of code. And that's important because as you'll see, we're going to be deploying code regularly, and that code is changing, and we need to be able to continually know that those code components are secure and well known to the environment. So leveraging a technology to help us with that is absolutely important. And here's a visual of that pipeline. And as we talked about earlier, you can see code injection all the way back in the build process, right? It doesn't just happen by hacking at the production environment. It can happen even early on in the development process. So we leverage NeuVector container security technology across that development pipeline or workflow, if you will, from development work into the build and test environments, into our staging environments where we're doing kind of final testing and analysis of the code that we built, and finally in the production environment. So again, an important technology to help us with not only the workflow, but the testing of our security capabilities across the workflow. And virtual patching is that ability to, as I mentioned, to push code to our environment at a very regular interval. Really, for us, that's going to be eventually days and even hours. We want to be able to make changes quickly that we experiment with and try with our customers through A/B testing and canary testing. And we want to push those changes on a regular basis. And we want to know that the code that ends up in the customer's hands is secure. So we need this virtual patching capability with a kind of zero trust approach where we analyze the code that's out there to make sure that we're looking at all the components as secure components that we can leverage in our code running in that running environment. Another piece that I mentioned early on is that we're not going to leap right to microservices. So we are going to write microservice architecture, and we're going to take that approach, but we have components that are already built as virtual machines. For example, the databases that we use, and we don't want to just rewrite those at first. We've got other issues that we want to focus on as a development team. So we really want to leverage those virtual machines and keep them in the same secure model that we're describing here in terms of the software stack that we're using. Linux and Kubernetes and Rancher managing all of that. And so we want to leverage the virtual machines within that model. So we're leveraging a technology from SUSE called Harvester that allows us to take those virtual machines and operate them in our Kubernetes environment with the same Kubernetes approach that we use with our containers. And that's really important for us because that helps us migrate into the microservice architecture world in a way that's more comfortable for us. We don't have to feel like we have to rewrite all of our code in one step. And that's really part of this approach that we're taking with the approach to how we transform. In our approach, and SUSE takes this same approach with transformation with their technologies. And again, the idea is to simplify the operating environments with standardized components and bring infrastructure as code approaches and automation approaches to those standardized layers that allow us to deploy quickly and with reliability, and then to be able to analyze the things that are running in that environment so that we're certain that what we have is the way we hope it to be and that it's doing the governance and policy and user authentication and security that we need it to do in the production environment. And that really helps us to become a much more accelerated business. It helps us move more at this speed of IT, the speed of IT development today. Let's dive a little bit into the developer experience, because it's also important that we think about how our developers are approaching this new modernized environment. So really, there's a number of objectives we have here. First, we need to ease our developers' approach to cloud-native development. We need to make it simpler for them to focus on the things that they need to learn and get those things working and experimented with early on, and not focus on hard problems like Kubernetes details. There's just a plethora of CNCF technology projects available today, and we want to bring those into our process as needed and build those componentry technologies into our application development in a secure and automated way. We need to focus on delivery. As I said, speed is the new currency, so we want to be able to build quickly and deploy quickly and experiment quickly. I mentioned we want to focus on innovation. We want our developers to focus on how they're building innovative code that's delighting our customers, not focused on the hard problems in the infrastructure stack itself. And to do that, we need to simplify the environment. We need to reduce complexity. We need to make technology choices that allow for automation, for infrastructure as code, and that give us a good visualization of what's running across our workflow from development into test and then deployment into production and runtime. And one of the tools we use to help with that is something called Epinio. So Epinio is really a platform for cloud native development. It allows us an easier on-ramp to deploying our containerized code into our Kubernetes and Rancher-based environment. Again, it's focused on application delivery, so it's making it simpler to get a container running in the environment so that developers don't need to worry about the details of some of that aspects, which allow them to then innovate on the technologies that they're building. You can see these are some of the design goals of Appinio: is developer experience, making it easy, leveraging some of these upstream projects that are so common in a cloud native development opportunity. Minimizing, making it easier, minimizing complexity for developers, and making it easy to install and deal with Kubernetes, right? One of the things we want our developers to be able to do is test right at their laptop or desktop. And to do that, they need a Kubernetes environment. So we'll talk about that as well. And you can see these are just some of the interfaces into what Appinio makes available to our developers that help us with that job of simplifying the access and on-ramp to the Kubernetes capabilities. I also mentioned that in our desktop environment, our laptop or our desktop, we need a simpler way for developers to engage with the Kubernetes technology itself. So we use something called Rancher Desktop, which is really an easier way to get Kubernetes on our laptop or desktop. So again, we have Kubernetes out in the production environment, we have Kubernetes in the test environments, but the first thing we want our developer to do is, once they've got a container, is to test it right on their laptop or desktop. And Rancher Desktop helps with that by making it easy to get a deployed Kubernetes environment on the desktop and makes it easy to then deploy code to it through Epinio. So we want that whole process to be kind of seamless for the developer. They just have those tools. It's easy for them to operate with them, even if they don't know a lot about Kubernetes. So let's put it all together. So we're really leveraging things that we already know well in our company. We know a lot about IT ops, so we know how to stand up services. But we want to leverage new Kubernetes-based cloud-native services or resources in our production environment. And that's much more of a DevOps kind of problem. We're taking what we know from our IT operations world and we're building it into this new cloud-native world. And that involves some of the things we've talked about: continuous delivery, A/B testing, canary testing, ways to bring testing all the way out to our customers. All the other aspects of a Kubernetes environment that need to be managed and monitored and dealt with are part of the DevOps process that we want to build and automate into our environment. And we want to allow that to be visible so that certain people in our company can be good at the operational side of the puzzle. So that, again, developers who are building new innovation can really focus on that innovation. And that comes together through our process workflow, through the way developers build, deploy, and then manage the code that they write. So again, the developers are using simplified developers tools that are meant for the job to do cloud native development and doing automation even at the desktop level, then pushing those pieces of code into the test environments, and that is all automated as well. Security is part of that process, right? That is security throughout the workflow of that process as we begin to test and analyze the code that's being integrated into the environment. And that's all then pushed out to a customer so that we see customers utilizing new features and then we get feedback about those new features, and that operational environment is automated and secure. So I've said a lot about the way we want to make these goals happen, and it's a big challenge to migrate and transform ourselves into this cloud-native development world, but it's also a very exciting opportunity in terms of digital transformation and ways to get closer to our customers. So I hope you've enjoyed the discussion we've had today, and please do reach out and get in touch with us about the work that you're doing in this area, and we'd love to hear from you and engage with you about that work. Thanks again. Take care.